we'll be getting into the beautiful world of unsupervised learning. We'll start to talk about unsupervised learning and talk about the different types of problem uh, domains that we have in unsupervised learning. What exactly is unsupervised learning, right? Uh, Now, if you remember, we had this conversation right on the first day when we were explaining about this beautiful example of fruits, right? So we had different examples of fruits, and we discussed how you can teach a small kid. How can you teach a small kid about different types of fruits? So you have to tell it. You have to show the example of the fruit. You have to show it a picture of an apple and say that, hey, it's an apple. You have to show it a picture of a guava, and you have to show it that, hey, it's called a guava. So this is how we will do supervised learning in the real world. We will show the machine lots and lots of examples of pictures. So in this case, we will show the machine lots and lots of examples of what apples look like. We will show the machine lots and lots of examples of pictures of how guavas look like. And based on that, we will build a model. And these are the XY combinations, right? Now, unsupervised learning is that kind of machine learning where the outputs or labels are not defined. It was a very crude definition that we had on first day, and what I will try to do now is I'll try to add more depth to this definition. We'll try to get a little bit more in detail as to how and what this means. What is the meaning of outputs not defined? So if output is not defined, what does it even mean? What are we trying to do? Okay, so that's the idea, but this is the broad definition. Okay, so you don't have any outputs, you don't have any output y's in unsupervised learning. So how is it possible? How is it possible that we don't have an output? Well, let's look at this. So we'll look at a very basic problem to start with, a clustering use case, a clustering or a customer segmentation use case. So clustering is one of the most important problem domains of unsupervised learning. So unsupervised learning is a broad category. So what are the different ways we can do unsupervised learning? One of it is clustering. What is it? What are we trying to do in clustering? As the name suggests, in clustering, we are trying to form groups and clusters of data. So imagine we have, we are looking at an Amazon or an e-commerce kind of data, and this is the customer level data that Amazon is tracking. As an example, it is tracking the amount of time the customer is spending in the application, because we all have the mobile app of Amazon, we all have the Amazon website. So next time you log into your account and you go to Amazon apps. Next time you log into your account and you go to uh, the website application. When you do that, what happens is Amazon is automatically monitoring the amount of time that you're taking. It is automatically monitoring the amount of time that you're spending on the application or the website. And it is also monitoring, if you make a purchase, it is monitoring against that same customer ID, against that same account, it is monitoring how much of purchases the customer is making from the website. So both the things they are tracking. So they're tracking the amount of time the customer is spending on the website, and they're also tracking the amount of money the customers are spending on the website. So both they are tracking. If you think about it, these are just features. If you think about this entire thing, these are just features. We just have features of the customer. So we are just tracking the amount of time spent and the amount of money spent. This is just inputs. This is just features. There is no output here. There is no labels that we are getting here, right? Think about it. So when you look at this kind of data, we don't really have any labels per se, right? There are no labels, just features. Just features is what we have. That's the way to look at it. What I can do is I can also try to visualize this data in a kind of a scatter plot, you can see. So along the x-axis, I'm tracking the time. Along the y-axis, I'm tracking the amount of money spent or the total value that the customer has contributed to Amazon. And this is how I can go and plot the data. Every single dot that you see on the screen, right? So every single dot that you see on the screen, it corresponds to what? Every dot corresponds to one customer. So each and every dot on the screen corresponds to one customer. And for every customer, we are tracking how much of time the customer has spent and how much of value the customer has spent, how much of time the customer has spent on the site, and how much of value the customer has spent on the site. how much of time the customer has spent, how much of value the customer has spent. And the moment you plot this data, again, you can see there's no outputs here. This is just inputs. This is just things we are observing, features, right? You remember those are some of the terminologies that we use. We call them X or inputs or features. These are just features, right? These are basically nothing but features. These are features of the customer, and they can be more. They can be more. You can track the um, total value of purchases. You can track number of orders, right? How many frequency of orders, when was the last order placed, all of that. You can for a customer you can track multiple things, but whatever you're tracking, ultimately you are only looking at the features of the customer. Okay, and then you can go and group the data into different clusters. So now you can group the data into different groups or clusters or similar groups and clusters. So you can see that, okay, these are customers who are very similar, because these kinds of customers have spent less time and less money. The engagement is very low. For some reason, they are not, opening the application or opening the website. For some reason, they are not buying. Maybe they are not comfortable with the online experience, whatever. On the other extreme, you've got customers who are spending a lot of time and a lot of money. So this is like very, very high engagement customers. So this is like a win-win for the company. And on the another category could be very interesting discovery. These are customers who are spending a lot of time. So they are spending a lot of time going through my products and all that I have got. But for some reason, they are not converting. This is a big loss for the business, right? Because at the moment you're spending time, you're actually using a lot of server resources, because to render these websites takes a lot of hardware, lot of computing power is needed to keep these sites running so that they're accessible to users. Now, if these users are accessing the site, if they're using all the compute and all that, but look, they eventually don't end up buying anything, and that's a loss for the business. Okay, so now a big part of maybe what they might want to do going forward is uh, how do we go and make the experience better for these customers, and how can we make them buy something. So the first part of the exercise is where we study our existing groups of customers. We identify what are the different groups and clusters of customers, and the next part of the use case would be to look at each and every one of those groups. Now you look at each and every one of those different groups of customers, and you try to figure out how can we target those groups, what can we do, and how can you effectively target those different groups and clusters of customers. Okay, so if you look at customers in group 3, so you identify, okay, these are customers who are very similar. These are customers who are spending a lot of time, very less money. So once you identify all the similar customers in that group, now you try to figure out what I can do, how I can target these customers more effectively, what I can do to maybe make them shop more. And nowadays, if you see a lot of these e-commerce platforms that we see, a lot of these grocery platforms that we see, if you're using Big Basket, Swiggy, Instamart and all, see, when you add items to the cart, they are constantly pushing you to purchase, right? So that is also very interesting. This is a cart prediction model, like a purchase prediction model. So the companies are looking at your cart value. They're constantly looking at all the items that you have in the cart, and they are trying to predict what is the probability that you will actually purchase. And if your purchase probability is low, they will dynamically give you some discounts and make you purchase, which is why, let's say you add some items in the cart and then you log off and you come back after 1 month, and the company will remind you that, hey, you have some items that are in the cart, so please do a purchase now and I will give you 30% off. Okay, so they are using machine learning to identify the probability of purchase. And if you're a customer who is likely not to purchase because you see the price is very high and whatever, so if you're likely to come out of the site, then they will give you a dynamic discount and make you purchase. Okay, so a lot of machine learning and behavioral analysis is used to you know entice customers into buying more and more and more. Okay, so we are also like becoming a more and more consumerist society. Anyways, so this is the big part of what we are trying to do conceptually when we are doing clustering. There is no outputs. You only have the input features, and you're trying to find groups or clusters of data. Okay, you look at the existing data and you try to find out the different groups or clusters of data. That's the core idea of what we are trying to do in clustering. And in a way, I would say it is advanced EDA. In a way, it is advanced EDA. Like, it's when we talk about EDA, what is EDA? EDA stands for exploratory data analysis. So EDA refers to exploratory data analysis. So a big part of what we are doing here is, I would say, kind of like advanced EDA. Okay, you're trying to do EDA in a more advanced manner. You're trying to explore your data. You're trying to find out the different groups or clusters, and you're just trying to do EDA in a bit of an advanced manner. Some other applications of this clustering could be anomaly detection in credit cards. Okay, we did a credit card case study already. Uh, a very good use case how we can translate this problem to a unsupervised learning problem, which is what actually happens. A key terminology that we use here is anomaly detection. Now, you have to understand when we talk about credit card transactions particularly, it is very hard and almost impossible to label the data in advance, right? So having the label data is very difficult and almost impossible. I'm saying almost because retrospectively you can still label. Let's say customer raises a complaint that, hey, some fraud happened. Then the bank will retrospectively label the data. That can happen. But initially, that data is not labeled, right? You're dealing fundamentally with unlabeled data. That's the way to look at it. So you're dealing fundamentally with unlabeled data. You've got some data which is not labeled. You've just got the transaction details that are present right now, X1, X2, X3, X4, X5, up to X7, X8. You've got the different features of the transaction, but and based on that, you're trying to identify anomalies. So again, you can see in this kind of data, there's no labels, there's no why. Okay, we only have the features of the transaction. You take the credit card out and you make a transaction. You do a swipe. You go to a merchant and you swipe something. When you do that, you're basically getting some data. Now, what kind of data do you have there? You've got date, you've got merchant name, you've got transaction value, okay, time of the transaction, what is the merchant category, all that. What is the country? Okay. So based on that, again, you are trying to find groups and clusters of data. It's again a kind of a clustering problem if you think about it. There are no outputs because you will never know. You will never know a fraud happens unless somebody reports it or unless somebody labels the data. And getting that data usually is very hard. Okay, again, there are different ways of doing it. There are semi-supervised learning techniques we use, but again, just to keep things simple, uh, think of anomaly detection as a clustering-based approach. You only have the unlabeled data, you have the transaction level data, and you're trying to find groups or clusters of similar transactions. And what you're trying to identify here are outliers. Okay, if you see lots of transactions are like this, like this, like this, and there is one transaction which is like this all the way here, so which is somehow very different. So most likely it's a fraud. Okay, so that's the filter. So this is one of the ways of doing unsupervised learning, clustering. Okay, another related area is going to be recommender systems, right? This is the other thing I pointed out. So recommender systems is like typically your YouTube, and you open up YouTube and YouTube recommends videos to you. You go to Spotify, open up Amazon Music, which recommends music to you. Okay, or you go to Amazon e-commerce, you see that entire homepage and how it recommends different products to you, or Netflix, how it recommends videos to you, or maybe Facebook and LinkedIn, how it recommends jobs to you, or maybe how it recommends social connections to you, maybe likely friends or people you may know. If you look at all these kinds of features, they are totally based on recommendation systems. The recommendation system also is a very good example of unsupervised learning. Now, I'll take a simple example to highlight the concept. So if you see, what I try to highlight here is a use case like Netflix. Okay, so there are two things, right? One is there are customers. So one is there are subscribers. If you subscribe to Netflix, you're a customer of Netflix. And second is there are items. Items are basically the movies or the videos or the documentaries that Netflix has in its catalog. Okay, all that we are trying to do, all that a recommendation engine like Netflix is trying to do is it is trying to find out the correlation between customers and items. That's it. If you think about it, there are no outputs here. It is just collecting data real time. It is just collecting data as and when different customers are signing in, different customers are watching different movies or videos or items. Okay. A more technical term to use here would be customers are interacting with items. You're a customer, you click on a link, that means you're interacting with an item. Okay. So you're studying these interactions. So Netflix is collecting this huge amount of data. It knows everything about the customer. It knows Where is the customer accessing the site from? What is the age of the customer? What kind of videos the customer has watched? These are all customer attributes. And you can basically build a profile of the customer. If you know the customer's history, what kind of things they watch and all that, you can build a basic profile about the customer. And then you are also studying what kind of things the customer is watching, the item attributes. Item attributes means, let's say I'm clicking on a movie Transformers. So now for the Transformers movie, what are the different attributes of the Transformer movie? Okay, it's an action movie, it's a science fiction movie. The director is this, the runtime is this, the box office revenue is this. It is very similar to that data set one of the folks showed us in the morning session. You will have the genre of the movie. What is the rating of the movie? How much people have rated in IMDb? Rotten Tomatoes, what is the rating? So those are item attributes. So this is all we have, right? If you think of a recommender system like Netflix, which is one of the most powerful and one of the pioneers in the field, right? A lot of recommendation system. Netflix has been one of the pioneers in this field, right? It's very good in what it recommends. So it is completely unsupervised. It's not labeled. The data is not labeled. It is not that somebody is giving an output value explicitly. No. You're simply studying features of the customer. You're simply studying features of the items that you're watching, and you're trying to draw correlations. You're trying to draw some mapping. And then on the basis of that, you're recommending that, hey, you know what? Customers like this typically watch items like this. Customers like this typically watch items like this. You're drawing correlations. And then next time you have a new customer, it's saying, hey, I think you might like this. See what I'm getting at? And the same idea you can extend to other platforms. Let's say if you go to Spotify, music, doesn't matter, right? So, users and items can be different in different places. If you go to Spotify, customers are the same, customer attributes, and item will be the song, music, attributes of the music. When it was released, runtime of the music, how many minutes, 3 minutes, 4 minute song, genre of the music, right? Artist name, all that. Some kind of audio features maybe. If you can look at some kind of audio features like is it how many beats per minute? Okay, what is the bass? What is the frequency, wavelength? So different types of maybe if you're doing some kind of spectral analysis, you can get some numerical features of the audio. Okay, so those are kind of things you can do. That is all part of the data basically. Okay, that's the idea. So I hope everybody has a good, solid understanding with what is unsupervised learning. It's not so the ideas are a little different. We will be solving the problems a little different. It's a lot easier. Okay, and and here we will not be following the same approach like the train test plate and building the model, evaluating the model, because there is nothing to evaluate, right? There are other ways to evaluate, which we'll see. Okay, which we'll see. What are the different ways to evaluate? We'll see. But we do not technically have a testing data here. Okay, so when you think of an unsupervised learning problem, we technically do not have a testing data. We don't have a evaluation data. We don't have a ground truth. We don't have something called Y to evaluate against. So supervised learning, we could do that very easily. We can say, hey, the model predicted this Y. Is it matching the actual Y? But here, there is nothing like it. There's no labels, right? So there are different methods we use to evaluate, which we'll see. And this is going to be a very broad discussion. Okay, so just to give you an idea in terms of how it's done. But the initial part is very important. And that's what we really encourage you to do at, in this part of the, in this phase of the session where we want you to look at a problem and we want you to identify what type of problem it is. That's one of the first things you should do, right? So let's say if you're looking at networking data, if you're looking at your network parameters data, and if you're just studying the data, it's a very good use case of clustering actually, because you don't have any labels, right? You're just trying to look at your data and identify and cluster that into different groups. You're trying to find out different groups, like, okay, these are groups like this, these are groups like this. And then retrospectively, you can go back and study those groups. What is group one? What is group two? What is group three?